These are the notes for section 2.4, part 2, and you will want to take these notes on graph paper. On these notes, we're going to go over x and y intercepts and how to solve equations graphically. So you might want to pause the video for a moment to take a second and copy down this table. The biggest spot you're going to need is in these columns that say graph. We're going to draw just like a little graph. I mean, on my graph paper, it is just 2 little lines tall, so you don't really need it to be that big. But you might want to pause and take a second to copy this down. Alright, so we're going to talk about x and y intercepts here, and we're going to fill out a little table to describe some of the things about them. So first we're going to talk about what the graph of each of these looks like. So an x-intercept is where a graph intercepts the x-axis. So as long as your graph is not horizontal or vertical, it's going to intercept both the x and the y-axis. So that point where it hits the x-axis, that point is your x-intercept. So when we write the coordinate of that point, it's going to look something like this. There's going to be a number, I'll call it A for now, and that's where it hits the x-axis. So let's say it hit it +3 on the x-axis. That A would be a 3. Then your y-coordinate, well, it's always sitting on that x-axis, so it's not up or down from the origin at all. So the y-coordinate is always going to be 0. For our y-intercept, it's kind of switched. So if we have a line where it hits the y-axis is the y-intercept. So when you're writing the coordinate, for your x value of that coordinate, you don't move left or right at all from the origin. So the x-coordinate is 0, and then your b, or your second number, your y-coordinate, will be whatever number it is where it hits the y-axis. So the biggest thing to remember is that in an x-intercept, y is 0. In a y-intercept, x is 0. So the opposite letter is 0. And that's going to be the key for how to find these things. So to find an x-intercept, what you're going to do is set your y equal to 0 and then find x. In a y-intercept, it's basically flipped. If we're finding the y-intercept, you're going to set x equal to 0 and then find y. So let's do some examples where we graph things using intercepts. So for example, we're going to graph the equation 3x plus 2y equals 12 by using intercepts. So one thing I want to point out really quickly, and we'll mention this later, is that this equation, 3x plus 2y equals 12, this is in what's called standard form. It's a little different than slope-intercept form, which is y equals mx plus b. And this is still shows a line. Basically, you have a number times x plus a number times y equals another number. Another way to write this is ax plus by equals c. It basically means x and y are on the same side. So this is in standard form. When something's in standard form, graphing it is way easier if you do it by finding the intercepts instead of trying to convert it to slope-intercept form. So the first thing we're going to do if we graph this by finding intercepts is let's find the x-intercept first. So what we're going to do to find the x-intercept is set our y equal to 0. So I'm going to rewrite that equation, but I'm going to plug in a 0 for my y value. And when you plug in a 0 for y, it's basically going to take out that term that has a y. So the 2y, well, 2 times 0 is just 0. So it basically kind of goes away. This is also, you can call this the cover-up method. I can show you it in class where I can actually show you how to cover it up, but basically you just cover up or take away that term with the y to find the x-intercept. So I plugged in a 0 for y. I'm left with 3x equals 12. So if we want to get x by itself, I'm hoping you can figure it out in your head right now. 3 times what is 12? If you aren't sure, you can divide by 3, and we get that x is 4. So our x-intercept is 4. And then the second thing we need to do is find our y-intercept. So to do that, we're going to set our x equal to 0. So I'm going to rewrite my equation, but I'm plugging a 0 in for x. So the same thing kind of happens here. 3 times 0 is 0, So I don't even really need to write 0 plus 2y. It's just 2y equals 12. Hopefully you can kind of think of what this is in your head right now. 2 times what is 12? Or you can divide by 2 on each side, and we get that y equals 6. So now we're going to graph these lines. You can see on my graph I went up to 6 on each axis on purpose because I wanted to make sure and have enough room to graph this intercept. So remember, you only need 2 points to graph a line. So having these 2 intercepts is enough to graph our line. So let's put those each on our graph. First I'll put my x-intercept as positive 4. So I'm going to put a point on my graph on the x-axis at positive 4. And then let's put my y-intercept at positive 6. And then you want to use a ruler to draw a line with an arrow on each end through those 2 points. And it should take up the whole graph, go from end to end. Just like that. So that's how you can graph using intercepts. Again, if it's in standard form, this is a really easy way to graph it. Just find the intercepts and graph it. I'm going to have you guys try one on the next screen. So I want you guys to try and make a new graph. I want you to try graphing x minus 5y equals 5 by using intercepts. So you'll find your x and y intercept, graph those, and draw a line through them. Pause this while you work on that. We're going to try another one together here. We're going to graph f of x equals 2x plus 5 using intercepts. So just like yesterday's notes, if that f of x makes you scared, remember you can write this as y equals 2x plus 5. It's the same thing. Don't let the f of x scare you. It's just like y equals. So on this one, to find our x and y intercept, one of them's already found for us. This equation is in slope-intercept form, so we can see the slope and we can see the y-intercept, and the y-intercept is 5. So we already have that one. I know you're probably like, I can just graph it right now. I just put the y-intercept on there. I just do the rise of 2, run 1, because the slope's 2. But we really want to graph it using intercepts because that's what the problem told us to do. So remember, to find our x-intercept, we need to set our y equal to 0. To find an intercept, you always set the opposite letter equal to 0. So I'm going to write 0 equals 2x plus 5. Now we just solve for x. So I need to get that x by itself on his side of the equal sign. I have to undo adding and subtracting first. So I'm going to subtract 5 first. So I'm left with negative 5 equals 2x. And then we just need to divide by 2. And I know I don't usually like decimals, but it's probably easier to put it on this graph as a decimal. So x is negative 5 halves, or you can think of it as negative 2.5 or negative 2.5. However you want to think about it, just to make sure you put it on the graph in the right spot. So let's put those 2 points on the graph. Our x-intercept is negative 2.5, so that's right between negative 2 and negative 3 on the x-axis. And our y-intercept was positive 5. So we're going to put our point on positive 5 on the y-axis. And then we're going to use a ruler to graph the line that goes through them. There we go. And make sure you put arrows on each end of your line because this line does extend forever. They didn't put any restrictions on our domain. And there you go. Alright, so now we're going to kind of switch gears here. Instead of talking about intercepts, we're going to talk about solving equations graphically. So this is the first example we're going to do. We're going to solve this equation for x, 1/2 x plus 3 equals 2. We're going to solve it graphically. So instead of doing it algebraically, where we just move everything to get the x by itself, what we want to do is we kind of want to think about this as an equation. Okay? So we want to find out, when does this stuff equal 2? So what we can do is, instead of thinking of that as a 2, let's just think of that as our y value. So I'm going to write y equals 1/2 x plus 3. I basically rewrote that equation, but I took out the 2 and replaced it with a y, and I kind of just wrote the y first. So now what I want to do is I want to graph this, and remember what I'm trying to think here is, since I replaced the 2 with a y, what I'm kind of asking myself as I do this is what is the value of x when y is 2? So if we're thinking about what our graph's going to look like, I'm going to look for when y is 2. So that's anywhere along this line. That means your y value is 2. I'm going to look for when does our line hit that, and then what is the x value at that point. And I know these can be tricky, so we'll practice this in class too. So let's go ahead and graph this line. I know that my y-intercept is 3, so I can put that on there. And my slope is positive 1/2. So that means I'm going to rise 1 and run 2. So I'm going to go up 1, right 2. So from that point, I can go up 1, right 2, up 1, right 2. But you can see I'm never going to hit that line where y equals 2. I keep going up in my y values. So remember, instead of going up 1 and right 2, I can switch both. I can go down 1 and left 2. And you can see I already hit that nice spot where y is 2. I'm going to put a few more on there just in case. We can put that line through those points. And then the spot that we're really worried about is this spot right here, because we're looking for that spot where y is 2. And we can see that when y is 2, x is negative 2. The coordinates of that point are negative 2, 2. So my value of x here is negative 2. And that's how we do that problem. All right. So what I want you guys to do is try one of these on your own. Even if you're confused, I want you to look back at this problem and try this next one I'm about to show you and really try and follow the same steps. I made it somewhat similar, so it shouldn't be too bad. I want you to try. Oh, never mind, I took it out. So I decided not to do that because it was going to take too long, but you guys will get practice with it in class. So we're going to do a word problem here. It's the last problem we do together, but there is one little page of notes after this. So our problem is, in 2012, the cost of an iPad was $630. At the time, AT&T offered a plan for you could get 250 megabytes of data for a cost of $15 per month. Actually, we would have done everything in this problem in your books in 8th grade math last year. So the first thing we want to do is write and graph a mathematical model for the cost. So if we think about our cost here, let's go ahead and make this in function notation because we love function notation. So let's say that C is our cost, and we're looking at our cost as it changes every month. So I'm going to make M my variable that represents the number of months that have gone by. So for our equation, we're looking at the cost in terms of the number of months. So I'm going to write C of M. That means, hey, this is an equation for the cost, and I'm inputting the number of months. So our cost is, let's try to write this kind of in slope-intercept form. So the amount it's changing by, or the slope, is, well, the cost every month you add on $15. So I'm going to have $15 per month. So 15 times the number of months plus that initial fee of $630 that you had to pay for the actual iPad. So there's our mathematical model that's written. Now it also wants us to graph this. So I've got a blank grid over here for myself. Let's see. We know that the cost depends on the number of months. So my cost is dependent, which means it's going to go on the y-axis. Let's do this in a different color. And the number of months is independent. It will go on my x-axis. Now, for me, this graph is really tiny for this marker that I have here. I think I can maybe make it thinner. Maybe I can't. I thought I could make this pen thinner. Oh, I don't know where it is. There we go. So I'm going to kind of skip more numbers than you maybe might want to. So what I'm going to do here is, let's start with 0 months right here. And then we'll do 1, 2, 3, 4, 5, 6, 7. All right, mine stops at 8. I don't have that much room. I think that's enough, though. And then we need to do the cost on the other axis. It starts at 630, so I'm going to do this little zigzag thing. I'm going to start right here with 630. And I think I'll go by 15s for each line, but I'm just going to write every 30 because I don't really have room to write for every single line here. So 660, 690, 720, 750. I'm going to go ahead and stop at 750 because if I look at part B, it says use your model to find when the cost is 750. So I'm just going to go ahead and stop on the y-axis at 750. We need to graph this, so our y-intercept is 630. So I'll put my y-intercept. And then every month we go up $15. So every time I go over 1 in the months, I'm going to go up $15. Over 1, up $15. And just continue that slope. Remember, yours could look a little different just based on what your axis was going by. After you get all your points on there, we're going to draw a line. We don't want an arrow on both ends because we're going to start at 0 months. We're not going to go into the negative months because that would be crazy. But we are going to continue up. It could go, I mean, you could, I don't know how long you could have this plan, maybe for the rest of your life. So it could go past 8 months, forever and ever. At some point it would stop because, I don't know, your iPad would break, or maybe AT&T goes out of business. I don't know. So go ahead and get that graphed. Now it says use your model to find when the cost is 750. So I want to show you how we can use both of their models. So we can look at our graph and find when the cost is 750. If I go over to my line and see how many months it was, it took 8 months for my cost to be 750. So I can figure that out on the graph by just looking at it. You could also figure that out using your equation, like plugging in 750 for the cost. So we would plug in 750 for C of M, that's our dependent variable, and then we would just get M by itself. So I would subtract 630 from each side. That is 120. And then I just need to divide by 15, and 120 divided by 15 is 8. So either way, you can figure out that it is 8 months. Pause if you need more time for this slide, but there's just one more slide of notes left after this. So like I mentioned in the beginning, we're looking at some equations in standard form for lines, and we've also been looking at them in slope-intercept form. So standard form is when it's written in this form. Something x plus something y equals some number. So an example of that would be like 3x plus 2y equals 12. I think we might have even used that equation earlier. That's standard form. It makes a straight line. It's linear. Slope-intercept form is when we write it in the form y equals mx plus b. So just some random example could be something like y equals 2x plus 8. So those look a little different. They're both linear equations. We could move either of them to look like the other one. So one thing you want to keep in mind is that these are both forms of linear equations. Okay? If you can write it in one of these forms, then it is linear. So your book's going to ask you about some problems. It's going to tell you to state whether they're linear or not. So some things you want to remember that kind of show right away that something is not linear is that if you go ahead and simplify your equation and you're left with an x squared in your equation, or an x cubed, or an x to the power of 4, anything like that, those are not linear. All right? Those are quadratic, cubic, quartic, quintic equations. Those are not going to be straight lines. Another thing that'll make something not linear is if you have a square root of x. That's not going to make a straight line. That's going to be a square root equation. And then if you have an absolute value of x, hopefully remember that those end up looking like a v. So those are also not linear. Now we might come upon more things later on in your, math career that are not linear, but those are the main ones we're going to see right now that kind of like try and trick you. That see if they want to know if they're linear or not. So anytime you see any of those things, you know it's not linear. If you can write it in either standard form or slope-intercept form, it is linear. All right, so those are the notes for section 2.4, part 2. Come to class with any questions you have.